Welcome to Math 104. We are talking about exponential growth and decay models. Later on in this video, we're going to cover power, power one, a logistic, and a logarithmic as well. So stay tuned for that. Now, if you have not watched the previous videos on cubic, quartic, linear, average error, and quadratic, please do so before you get started with this video, because we're going to be kind of skipping over the foundations portion. So in our problem, it's telling us that we will be modeling with exponentials. So that is what we're going to be learning here today. So it says, suppose a company develops a product that is released with great expectations and expensive advertising, but sales in thousands suffer because of bad word of mouth and from dissatisfied customers. So here you'll notice that we have your month and your sales, which we have then put into your table. So if you haven't done that, I would definitely pause the video and start there. So we also created a window based on what we're seeing from your X and your Y values. Again, if you don't know how to do that, please go back a few videos where we talk about your window. So this is asking in part A, is it a growth or a decay model? Well, we're going to be looking at the direction of your data values, and it is going in, it's going down, so it is decreasing. So this is a decay model, and because it says, how can you tell? The sales are decreasing with time. So over the monthly period, we are decreasing with decreasing in our sales. So now it says find the exponential function that models the data. So we are going to be getting your equation. So you have y sub 1 with the squiggly, a times b to the x sub 1. This is going to be your exponential equation. Now we are going to hit the log mode. So now we have your new a and your b values. So it is super key that we're hitting log mode for our examples in for exponential. So you'll notice you'll have 999.78 as your A. So we have y equals 9.99978, and it doesn't tell us for rounding, so we're just going to leave it to 2 decimal places. Let me try that again. Times your B, and I would use parentheses here. Your B is 0.78, and we'll just round to 2 to keep it simple, raised to the X value. So that is just following along with your formula here. Then it says predict in what month sales will be this value. So we know that Y is equal to 547. We also know that with your equation from above, that's going to go into another sign. So first thing we're going to do is type in your equation that we have from before, raised to the X. So there you're going to see the exact same line. We're also going to enter in y equals 547, and where they intersect is going to be your solution. So in what month are sales going to be this value? So this is when X is equal to 2.4. So in the 3rd month. So we are well into your, so we've completed your 2nd month, right? And now we're completing or working on your 3rd. So we're in your 3rd month. So we could just say month 3. Then you'll notice too, between 2 and 3 is going to be this value here. And again, it might be super specific on your homework as to how many decimal places or how many months there will be. Then it says find the average error. So I'm just going to go back here, and we're just going to click out of these values. And when it says your average error, well, we do need your SSE and your average error here. So let's go ahead and make sure that your residuals, which are in E1 right here, if you wanted to plot them, you can. Again, it is just about perfect. And we can see that perfection in your R, your correlation coefficient, which is -1, which is as close as we want to get. So we cannot be more perfect than a positive or a negative one. So with that being said, we're going to be looking at your average error here, making sure that E sub 1 is accurate. So we have your average error of 0.27. And you might be thinking, well, shouldn't the average error be 0 if your correlation coefficient is -1? This is being rounded, so it is just likely that your correlation coefficient is 0.99999 with a few values maybe being off by a certain degree. So that rounds out your exponentials. Now we're going to go into your logarithms. Again, I would suggest really saving these equations or saving these sheets, because as you're going to notice with your project, it's going to be really easy if you have these, if you can just copy and paste them into one sheet for your data. Let's take a look at one that I'm going to do. I called this one power, quad, and logarithmic. The reason for that is, let's see, where did it go? I'm going to be pulling one from your homework. This is from 5.4, question 4. So, and if you actually click out and then back in, notice that it says that we don't often cover the power functions. So on the project, you're not going to be using a power function. So just look on your graphing calculator if you're not using Desmos for the PRW or power regression. For us, I'm going to show you the power regression here. And we'll just show completed so you can kind of compare your answers. So again, we've entered the data, we've double checked it. So now let's find the power function. Make sure you go and edit your window so that you can clearly see your graph, and make sure that you're able to select these. You can zoom in or even make it a little bit bigger. And notice that this dot right here, the fourth one, is a little bit further down. So that's why this one is selected. So when it says the equation of a power function, it's giving us the setup for, again, y sub 1, your squiggly line, and then we have a times x sub 1. I guess you don't have to have x sub 1 or times raised to the b. So this is going to be your what is it called? Your equation setup if you're going to use the power function. Now, again, I'm going to say it one more time. You do not need to use your power function for the project. It is really just for this question. I really like the comparison between these two primarily, and then I can't find a way how to get out your power function. We're also going to be clicking the log. Oh, actually, did I make an edit? Oh, I need to change the values because I stepped away from here for a second. So 6.7, 7, 3, 9, and 10. Perfect. So if there is going to be an issue, it would be on this power one. So we're going to be hitting this log mode. So typically, if you're having an issue with completing some of your equations and your data is right, if it gives you the log mode, go ahead and try and hit the log mode, because you'll notice that your answers can come out a little bit differently if you don't hit it. So really, just your exponential and your power function, and then rounding. And let's go ahead and do it again, but for a quadratic function. So y sub 1 ax squared, and we want to make sure that this one has sub 1 plus bx sub 1 plus c. And again, your correlation coefficient, if we are looking for it, we would square root that value because it's r squared, and we do not need r squared. We're really looking for just r, which I forgot to round, 985. So that's going to be 9925. And your logarithm. So your logarithm, which is necessary other than y sub 1, has the setup of a plus b ln of x sub 1. Now we do not need to hit the log mode for this particular logarithm, so we're not going to be hitting log mode. It is just for your power function and your exponential. So here you'll have these values, and again, just rounding to 3 decimal places on that question. And if you're looking for your R squared, your correlation coefficient R, 9607. Now between the two, which one is better? Well, definitely the top one is going to get us closer to a perfect model. So if we were kind of between all 3 of these, we can definitely rule out your logarithm because your correlation coefficient was a lot less. And then between the two, it would just be a visual comparison. And then you can also compare your correlation coefficient, this being 0.9949, so 0.995, and this one being just slightly less. So really your power function would be the one to go. It would be the better of the fit. So it's hitting really close to just about all but one. If we were to do the same thing, but for the other one, you'll notice that it is missing more than one, and it has a bigger beep. And one more over here, this one misses a lot more. So if we had to be between any, it would be the power function for the win. I'm going to go ahead and save that. And our last one, we are going to be talking about the logistic function next. Let's see if I can pull up our last one. So we have logarithmic. I hope I said logarithmic. Let's see. No, that's not logarithmic. That should say logistic. I'm so sorry. Oh, I know, it is. There we go. Okay, well, we can compare the two. All right, so we have your equation. Don't worry about the fill in the gaps. We're really just interested in your modeling. So we've entered in your function, your data. We found a good window. So if you haven't done that, please pause and do that for me. You'll notice I already went ahead and did your average error along with it. Okay, so let's figure out if this is going to be, or what models they could be, right? So anything is up for interpretation. Let's say I wanted to figure out between the two, logistic or logarithmic. So we could be between the two, right? Who knows? So let's try out your logistic or logarithmic first, because we just came in from that video where we made that comparison. So we have y sub 1, a plus b, ln of x sub 1. So what do we think? Is it going to be a good fit, bad fit? Well, it isn't quite hitting all of your points. So it's not going to be a perfect, and we can see that from r squared when we take the square root of it, 981. It does get us close, so 0.9905. So it's decent. It's not a great fit though. It's not a good fit. I'd say it's okay. If we wanted to plot your residuals to find your average error, we're just going to have to switch this so that it matches your what is it called? Subscript. So your average error overall. So let's talk about your logarithmic as an average error of 0.83, which is good in comparison to the y values / data. We can say visually it missed 1, 2, 3, 4, 5 points, but came close to several others or hit directly. directly through one and a couple. This would be considered an okay fit, definitely not a good fit. The correlation coefficient is equal to 0.99. What did we say? 01, 05, which supports the conclusion. Now let's compare it to a logistic. So we can kind of click out of that one and look for your logistic. So your logistic, same kind of setup, at least for the beginning. We have C over 1 plus A E. Now this E is going to be considered that irrational number that we talked about back in chapter, chapter 5.1, negative BX sub 1. There we go. Now what's nice about this is that it actually pulls up your correlation coefficient, or so that we can get it, 9972. So we can see your correlation coefficient for this one, R is 0.9986, right? So if we're comparing the two, your logistic function has a lot stronger. The logistic function has a stronger correlation coefficient, being closer to 1, which means it should be a better fitting graph. And we'll take a look there in a moment. So it should be better fitting. So looking at here, notice that it does go through several more points. It definitely misses one and kind of nicks the other, but in a whole, it definitely hits the majority of the points. The graph hits the majority of the points through the center and misses only one completely. And let's take a look at your average error. So we should kind of conclude that your average error for this should be a lot less. Now, if we were to plot them, they should be in E2. So we're going to change that subscript to a 2. And then notice your average error is small, so 0.32. The average error is 0.32, which is closer than the log function. Average error of 0.83. So on a whole, if we're between the two, the better fitting graph would be the logistic function. So hopefully that helps clear up any sort of questions if you're having problems with logistic, logarithmic, exponential, power functions if you tried your homework early. So definitely good luck with your homework. Send me any questions over email.